You want to react 10 grams of iron 3 oxide with 10 grams of carbon monoxide to produce iron and carbon dioxide. Which of the reactants is limiting? So we can actually tell both. We can figure out which is limiting and which is in excess. You really much can't find one without the other anyway. So first step in any of these questions is it's very similar to stoichiometry. You need to write a balanced equation. So there we go, and to balance it we need a 3 here, a 2 here, and a 3 here. Next, since we have an equal mass of each of these two things, we need to work out the number of moles to figure out how many of them we have. Remember, mass is just how much it weighs, not how many of them you have. So if one's heavier than the other, it'll take less of them to add up to 10 grams than if one is lighter than the other. And so a perfect ratio here would mean we should have exactly 3 times as many COs as we do iron oxides, since it's a 3-to-1 ratio. And basically what we're going to do is check to see if that's true. If there's too much CO, more than 3 times the number of the Fe2O3s, then it's in excess, and if there's not enough of them, if there's less than 3 times the number of them, then we know it's the limiting reagent. So what we'll do first then is figure out the number of moles of one of these things. It doesn't matter which one you do, because you're just going to compare the other one to it. In this case, I'll use the iron 3 oxide, and figure out its number of moles and compare it to the CO. You could have just as easily used the mass of the CO and done the same thing, and you still should get the same answer. And in fact, you should probably try that once you're done looking at this example to see if you still can see that which one's limiting and which one's in excess. So for no good reason, I will use the iron 3 oxide to start with, since it came first in the equation. So to find the number of moles, I take the 10 grams and divide it by its molar mass, and I get 0.063 moles. Now what I want to do, very similar to stoichiometry, is compare the mole ratio then between the two reactants here, iron 3 oxide and carbon monoxide, and that is a 1-to-3 ratio. So if I put in my 0.063 moles of the iron oxide, and if I multiply it by 3 and divide by 1, I get 0.189 moles, which would be exactly 3 times the number of iron 3 oxides, which would be a perfect ratio, meaning there'd be nothing left over and not too much of anything. It would be perfect. So now that we've done this, we've worked out the number of moles of one and then the mole ratio to figure out how much in theory we need of the other. What you do next is now figure out, well, we know what it is in theory. It should be 0.189 for the carbon monoxide. But let's just see what it actually is, since we actually have a mass for it. We were given that it's 10 grams. So let's put that in and we'll compare it. So 10 grams divided by the molar mass of carbon monoxide, which is 28.01 grams per mole, gives us 0.0357 moles. So 10 grams is quite a bit more than what the theoretical value should be of 0.189 moles. And so what that means then is 10 grams is too much, and therefore if it's too much, the CO is in excess, which makes the iron oxide the limiting. So what you should do now is go back and retry this, only find the number of moles of carbon monoxide first, do the mole ratio to figure out how much Fe2O3 you should have, then work out the number of moles of the Fe2O3, and you should find that you do not have enough, and therefore it would be limiting, which is what we found this way, just doing the opposite.